All right, let's talk about what we call the real number system. The real number system, when we talk about it, we're going to just refer to them as sets. And you'll notice that I use these curly brackets to signify a given set. So let's go ahead and take a look at what the sets are that make up what we call the real number system. The first set that we're going to talk about is called the natural numbers. Now the natural numbers, you can think of those as the counting numbers. So if you were to start counting, you would start counting at 1, 2, 3, and you would continue counting forever. And by forever, we just use ... to signify that. So remember, we're talking about sets, so we want to make sure we use the set notation for that. So the curly braces that you see here. Now, the next set is called the set of whole numbers. The only way the whole numbers differ from the natural numbers is they also contain, or it also contains the number 0. So 0, 1, 2, 3, again, ... One way to help you remember this is that the word whole contains an O, and the set actually contains the number 0. So that's the difference between natural and whole numbers. You'll notice that the natural numbers is a subset of the set of whole numbers. So in other words, if I look at the natural numbers, I can see that the natural numbers are contained within the set of whole numbers. So again, the natural numbers are a subset of the whole numbers. Now the next set we're talking about is the set of integers. Well, the integers contain the set of whole numbers, and they also contain the counting numbers if you're going backwards into the negative numbers. For example, -1, -2, -3, so on and so forth. So the way we write that is we start with -2, comma, -1, 0, 1, 2, and ... because it goes forever. Now the way we signify going forever in the negative direction is we also use a ... So we use a comma, ... and once again a curly brace. So it's important at this time to just realize that the integers contain the whole numbers because the whole numbers contain 0, 1, 2, ... So we could say that the whole numbers is a subset of the set of integers. And we already said that the natural number is a subset of whole numbers, so therefore the natural numbers is also considered a subset of the set of integers. So let's go ahead now and talk about the set of rational numbers. What do they look like? The rational numbers simply look like this. We take some number a over some number b. Now the numbers a and b are considered, or they have to be integers. So what you'll notice when you write or express any or any number as a rational number, you'll notice that the decimal will either terminate which means it ends, or it will repeat. So examples of this, once again, if you write a fraction as a decimal number, the decimal number either terminates or it repeats. So an example of a terminating decimal would be, for example, 2.5. Repeating an example would be something like -7.33, where the 3 repeats forever. So again, examples of rational numbers would be any number that, as expressed as a decimal, will either end, which means terminates here, or it repeats in value. It could be, even for repeating, it could be more than one number repeating. For example, 6.454545, and again, that repeats forever. So, if a rational number is a number that can be expressed as a ratio of two integers, then an irrational number cannot be. So what it does as a decimal, if you express it as a decimal, is that the decimal will never terminate and it never repeats. One of the common examples of that would be something like pi. Now most of you probably heard pi being 3.14, but that's actually an approximation. So what we do is we use squiggly lines to mean it's about 3.14, but if you look on the calculator at the value of pi, it just does not terminate. It continues as a decimal number. As a matter of fact, if I show this value to you on the calculator, I just type in the number pi here, it looks like this, 3.14159, and notice there is no termination or repeating of any decimal numbers. Now you might say that it eventually stops down here at 5, and this is only because of the limitation of the calculator. This value goes on forever and ever and ever. Another example of an irrational number would be, for example, the square root of 5. So they are numbers that cannot be expressed as a ratio of integers. So let me say that one more time. An irrational number cannot be expressed as a ratio of two integers. Now, the set of real numbers just simply contains all of the numbers that we've talked about before. So that's what the set of real numbers involves. So the real numbers contain natural numbers, they contain whole numbers, integers, rational numbers, and irrational numbers.